Welcome to Mathematics tutorial. The topic is Algebraic Expressions. Before we start, आइए आपको एक शायर की कुछ लाइन सुनाता हूँ. शायर कहता है, नज़ाकत है न खुशबू और न कोई दिलकशी ही है. नज़ाकत है न खुशबू और न कोई दिलकशी ही है. गुलों के साथ फिर भी खार को रब ने जगह दी है. गुल फूल, खार कांटे. गुलों के साथ फिर भी खार को रब ने जगह दी है. वही करते हैं दावा आग नफरत की बुझाने का. वही करते हैं दावा आग नफरत की बुझाने का, कि जिनके हाथ में जलती हुई माचिस की तीली है. कि जिनके हाथ में जलती हुई माचिस की तीली है. हटो करने दो अपने मन की भी इन नौजवानों को. हटो करने दो अपने मन की भी इन नौजवानों को. ये इनका दौर है, इनका समय है, इनकी बारी है. ये इनका दौर है, इनका समय है, इनकी बारी है. थैंक यू. Today's topic is Algebraic Expressions, a very important topic. Once you understand, then it will be very easy for you to add to algebraic expressions, to subtract, and in my next lecture I'll teach you how to use board mass. Then you will learn even different types of brackets, how to open, and then the 4 basic maths operations, how to use in which order, which is very, very important. So first let's understand what algebraic expressions are. So some important terms. The first is constant. Constant. A constant has a fixed value. No change, constant. A fixed value. 2, fixed. 3, fixed. So a constant. 100 is a constant because its value is fixed. Minus 15, a constant. The value is fixed. Alright? Etc. The next important term is variable. I have seen sometimes children they don't understand which one is a variable in the given expression and which one is a constant. What is a constant and what is the variable in this expression? Alright. And of course the coefficient also, because okay, that I'll tell you later on. So first, variable. A variable can take various values, different values, and we denote variables by either x or y or L or M or N, etc., etc. These are the letters which we use to denote a variable. And as I told you, a variable can take various values, different values. It's not fixed. Clear? Okay. Now the next is the expression. What is an expression? An expression in mathematics is a mathematical statement involving at least two components. Once again, listen, you may note down. An expression in mathematics is a mathematical statement involving at least two components: numbers and variables. Let me tell you like this once again, please listen. An expression in mathematics is a mathematical statement involving at least two components, that is constant or variable. Constants or variables, or a combination of constants and variables. A combination of constant and variable. This is called an expression. I'm not talking about algebraic expression right now. I'm telling you about an expression. So I hope expression is clear. Now the expression we can divide into two types. One is arithmetic expression and the second type is algebraic expression. Alright, here you will find I have written these expressions. In this you will find some arithmetic expression or number expression and some algebraic expressions. It's important to understand what an algebraic expression are, what algebraic expressions are, or what an algebraic expression is. Alright, and of course at the same time what an arithmetic expression, because an arithmetic expression can be evaluated, whereas an algebraic expression cannot be evaluated. And for this arithmetic expression or number expression, we'll be using board mass. Actually, I wanted to take the lecture on board mass only, but before that I wanted to tell you about expression, because there I'll be telling you, oh, these are the expressions, and then you'll be wondering what the meaning of the expression is. Alright. So, what is an arithmetic expression? An arithmetic expression is an expression with a minimum of two numbers. Arithmetic expression or number expression. So an arithmetic expression or a number expression is an expression with a minimum of two numbers, or more than two. With a minimum of two numbers, you can see here only numbers. With a minimum of two numbers and at least one maths operation. At least one basic maths operation. And what are they? Addition, subtraction, multiplication and division. Fine. So you can see here the numbers, and fortunately here we are using two basic maths operation. One is plus and one is multiplication. Alright, addition and multiplication. Here also multiplication and addition. Alright. So this is about arithmetic expression or number expression. Alright. Now the next is algebraic expressions. So algebraic expressions are formed by combining numbers and variables with at least one basic maths operation. It is one. And what is that? Addition, subtraction, multiplication or division. Alright, so you can see here the algebraic expression, a combination of numbers and variables. Alright, or only variables. But it's a combination of numbers and variables. You can see the combination here. See, variable is x and number is 2 here. Numbers 2 and minus 1 or 1. Here number is 7 and the variable is x square. Alright, a combination of numbers and and algebraic expressions are found by combining variables and constants using at least one basic math operation, that is addition, subtraction, multiplication or division. And as I told you before, an algebraic expression cannot be evaluated unless and until the value of the variable in the algebraic expression is given. Alright, so they are the algebraic expression. Now if you see here, in this where I have written expression, you will find algebraic expression also and arithmetic or number expression also. Alright, and when we split it, when we divide, then arithmetic separate and algebraic expression. So these are the algebraic expressions. And you can see here there are two parts. 2x is one part and minus 1 is another part. Alright, each part is called the term of the algebraic expression, which is very, very important. Let's understand the meaning of term or terms of an algebraic expression. So in this algebraic expression, there are two terms. One is 2x, first term is 2x and the second term is minus 1. Actually, terms are added to form a mathematical expression. So this minus goes with this 1. Minus 1 is the second term, and that's why we don't talk about subtraction. We say that terms are added. So in this case 2x is one term, 2x is one term, and then 2x is one term, and then the second term is minus 1, and we are adding. So 2x minus 1 we are getting. Alright, so one term is minus 1 and one is 2x. So there are two terms. One more thing, one more important thing I am telling you, because here there are two terms, so we call it a binomial. Two terms. If there is only one term in an expression, then we call it a monomial. So one term, then the expression is called a monomial. Two terms, then we call it a binomial. Three terms, then we call it a trinomial. Like that. Alright, so that also please remember, monomial, binomial and trinomial. What is this? This is one term. 7x square is one term. Alright, and the factors of this 7x square are 7 into 7x and x. You can write down 7x square as 7 multiplied by x multiplied by x. Alright? So this is a monomial. Here there are two terms in this algebraic expression, so it will be a binomial. Again, this is a monomial. Alright. So I hope expression, arithmetic or number expression and the algebraic expressions are very, very clear. And please remember that terms are added to form an algebraic expression. Fine. Now, so terms are clear, algebraic expressions are clear, monomial, binomial and trinomial, they are also clear. Alright. Now the numerical factor, the numerical factor of a term is called its numerical coefficient. What is the numerical factor of this term? 2x. 2 is the numerical factor, not algebraic. This is called algebraic. This is called number, no? So numerical factor. Alright. So the numerical factor, in this case it is 2, in this case it is 7, in this case there is nothing, means 1, in this case it's -5. The numerical factor of a term is called its numerical coefficient. Numerical coefficient. So the numerical coefficient of x is 2, because 2 is the numerical factor. Alright? In a more general way, we call coefficient, and suppose we are writing 2xy. So the coefficient of xy is 2 in a more general way. Here we are not saying numerical coefficient or what. So the coefficient of xy is 2, the coefficient of y is 2x, the coefficient of y is 2x, the coefficient of x is 2y. Please understand, the coefficient of x is 2y remaining, the coefficient of y is 2x, the coefficient of 2 is xy. Alright, so like that we talk about the coefficient of a term, of a variable or a number. Is that fine? Okay. Now, after this, we will talk about the, as I told you, terms are added to form expressions. For example, here, in this there are two terms. One is 4x square and the other one is minus 3x. As I told you, we say that terms are added. So this minus goes with this term. So minus 3xy is the second term. Please remember. Here there are two terms. One term is 4x square and the second term is minus 3xy. And we add 4x square and minus 3xy and we get 4x square minus 3xy, which is an algebraic expression. So terms are added to form expressions. Fine. Now next is I will give you one question also, but before that let me tell you about like and unlike terms. What are like terms and what are unlike terms? Alright. So in like terms, the algebraic factors are same. You understand? In like terms, the algebraic factors are same. And in unlike terms, I have written here same algebraic factors. If you have two terms, or two or more than two terms, and if they have, it's very important, please listen, and if they have same algebraic factors, then we say that they are the like terms. And if a term is, if two terms are not like terms, then they are unlike terms. That means in unlike terms, the algebraic factors are different algebraic factors. Getting? So, let me rub this. Same algebraic factors. If I write suppose mn square, or simply mn, suppose mn here, and one is minus 4mn and one is 7m. 7 mm. Alright. You have to see the algebraic factor. See, the algebraic factor is here mn. Alright. The coefficient, the numerical factor, the coefficient is 1, which you don't write. 1 we don't write. Alright. If you are not okay with it, then let me write down this phi mn. Phi mn. So phi mn here, minus 4m here, and 7mn here. Which are the like terms? The algebraic factor mn, the algebraic factor mn, same in these two terms. So same algebraic factors, variables. So these two terms are like terms because they have the same algebraic factors. Alright. And if you talk about these two, so here the algebraic factors mn and here it is m. They are not same, they are different. This is m and this is mn. So they are unlike terms. I know what is important while deciding whether two terms are like terms or unlike terms. The numerical coefficient you don't have to see. You don't have to see the numerical coefficient, and at the same time you don't have to see the order in which the variables are multiplied. Yes, these two things you don't have to see. The numerical, see here the numerical coefficient is 5 and here the numerical coefficient is 7. So that we are not bothered. That we don't consider, we don't see while deciding whether the terms are like terms or unlike terms. And the order in which the algebraic factors are multiplied. Alright, that order. So these two things. The order in which the variables are multiplied, alright, that also you don't have to see in the terms. For example, if you have suppose 3ab, and here you have 4ba, alright. This is AB and this is BA, they are same. AB is equal to BA. So first thing, we don't see the numerical coefficient. Alright. While deciding whether the two terms are like terms or unlike terms, we don't see the numerical coefficient. So we don't have to see 3, 4, minus 1, minus 4, minus 13, nothing we have to see, numerical coefficient. Second, even we don't have to see the order in which the variables are multiplied in the terms, whether it is AB or BA, because AB is equal to BA, they are same. Alright, got it? So like terms where the same algebraic factors are there, and unlike terms where you can write down here unlike terms. Here only I am writing, right? Unlike terms where it's different, different algebraic factors. Different algebraic factors. So like terms when same algebraic factors, and unlike terms when different algebraic factors. For example, here this is m and this is mn, different algebraic factors, so they are unlike terms. One or two more examples you see. One or two more examples you see, and then I'll give you one question to solve with the solution, with the answer. But first you try and then you see the solution. Suppose you have here PQ, and here you have minus QP. Are they like terms? Yeah, they are like terms because PQ and QP, they are same, they are like terms. And now you have PQ square. No, see the power. It's different. PQ and PQ square, they are different. Alright, so they are unlike terms. They are unlike terms. Got it? XY and x square y. They are different. They are different. But you have to see the power also. Power. Here x raised to the power 1 and here x raised to the power 2. So the algebraic factors are not seen. Getting? So please write down. Note down. These 2-3 points you need to remember. Ignore the numerical coefficients as I told you. Only see the algebraic part of the terms. Algebraic part. PQ, QP, PQ square, that you have to see. Second, check the variables in the terms. They must be the same. The variables must be the same. Alright. Next, check the parts of each variable in the terms. Parts of each variable. For example, here the variable P and here the variable P. See the power. So check the powers of each variable in the terms. They must be the same. Here the power of Q is 1 and here that of Q is 2. So they must be the same. They are not same. So that's why they are not like terms. Alright. So the point is, check the powers of each variable in the terms. They must be the same. Fine. And this is how we can. So first of all, we need to check the variables if they are same or not. So PQ, they are same, and then we have to check the power of the variable. If the power is same or not. Is that fine? Now there is one question. Question is this clear? You don't have to see the number while deciding whether the terms are like terms or unlike terms. You don't have to see the numerical coefficient, and then you don't have to see the order in which the variables are multiplied, whether it is AB or BA, whether it is MN or NM, whether it is PQ or QP, or like these two things. And other points are, you have to ignore the numerical coefficient, that you don't have to see. You have to only see the algebraic part of the term, and then check the variables in the terms. They should be the same, PQ, PQ. And next you have to check the powers of each variable in the terms. Powers of each variable, right? Powers of each variable. So here the variable is P, here the variable is P. Power is 1, 1. Here the variable is Q, here the variable is Q. But the power here is 1 and here is it's 2. So they are not same, they should be the same. Got it? So that means one or two more examples I give you. Wait. So it means 7xy square and suppose 2 x square y. See the variable, they should be the same, so they are same. X, y, they are same. But now you have to see the powers of the variable. Here we have x, power is 1, and here we have x, power is 2. Here it is 1, here it is 2. They must be the same. They are not same. That means 7xy square and 2x square y, they are not the like terms. They are unlike terms. Is that clear? It's very important because I have seen this is important even for higher classes also, but as far as class 6, 7 and 8, even 9, and as I told you, even in the higher classes also, these classes are concerned, sometimes the students can't decide which terms are the like terms. Because once you decide the like term, then only you can add. No, the two like terms are added and the two unlike terms. Alright. Sorry. Only like terms you can add. Alright. For example, if you have 7m and here you have 4m, then you can add 7m plus 4m. You can add like this 7m plus 4m, and that gives you 7 plus 4, 11m, right? But if they are unlike terms, then suppose one is 7m and the other one is 4n, then you have to write down like this, 7m plus 4n. Alright, you cannot add like this because they are not the like terms. Alright, fine. So once you are in a position to decide which are the like terms, then easily you can bring all the like terms together and then you can add or subtract. It's a very, very important, very basic thing which one should know, whether you are in class 6 or 7 or 8 or 9, etc. So whichever, because these are the basic things, no? These are the important things. Fine. Now one question I am giving you. Question you can see. The question is, which of the following pairs of terms are like terms and which are unlike terms? Give reason also. You have to give reason also. The first one is 3x, comma 4y. Second is 5ab, comma minus 6ba. The order is changed. Please remember, and as I told you, you don't have to see the order. Third, pq squared and 3pq. Fourth, minus mn squared and minus 3mn squared. And fifth, 8xy squared and minus 5x squared y. Alright? I am giving you the solution also. Fine. I am giving you the solution also, one table I am giving you. But first you try. On your own you try. How much I explained to you, if you have understood, please try and write down all the answers. Solve the question and then you match. You see what you have done and what the solution has been given. Are the same or not? Alright, so I hope things are very, very clear. Everything is clear. Now, in my next lecture, let's see if I continue with this algebraic expressions, or I start first how to use board mass. You know, board mass, and then I'll also tell you about big mass and PEMDAS also. Alright, in America they use PEMDAS. Alright, so that we will discuss in detail in my next lecture. Okay then, thank you so much. Thanks.